Hi everybody, this is Tim Urdan, author of Statistics in Plain English, and in this video I'm going to do a really quick explanation of how to do a cluster analysis in SPSS. Now, cluster analysis is very complex. There's a lot to it, so I'm just going to do sort of the one version of it and show you how to interpret it and kind of how to use it. So what we do is let's start by doing the cluster analysis first, and this is classify. There's, as you can see, several different ways to do a cluster analysis. We're going to do a hierarchical cluster analysis, and we'll do it. We'll use these three variables as our clustering variables: valuing of English classwork, family orientation, which is a desire to sort of make the family proud, be in a position to take care of the family. So really thinking about your family as a reason for doing well in school. And then appearance goals. These are the desire to appear smart, to make other people think that you're smart, that kind of thing. Okay. Now, when you do a cluster analysis, you can select how many clusters you want to save out of the analysis. And if you want to, say, do a cluster analysis where you save 5 clusters, you can do that. You can put that in here. What I want to do, though, is actually a range of clusters. I want to save the 3 cluster, 4 cluster, and 5 cluster solutions. So I'm going to put those numbers in and click that. You can get the agglomeration schedule. You can specify a certain number of clusters. So I'm just going to run it. See what we get. Okay, the agglomeration schedule. This is putting clusters together one case at a time. And at each stage of the cluster analysis, another case is added to one of the clusters. So it's not, it's a very big table. It includes all the cases. A little bit confusing. And then you also get this graph that shows you at each stage where clusters were combined to form a smaller number of clusters. This goes on for a while. So it's a little bit difficult to interpret. Okay. What you can do, really what you get out of this cluster analysis is, if I go back to the data set, you can see that it is saved. Let me make this bigger. It's saved the 5 cluster solution, the 4 cluster solution, and the 3 cluster solution. And that's what I want to be able to analyze now. So if I run a one-way ANOVA, and in my one-way ANOVA, I'm going to use my clustering variables, which were appearance goals, family orientation, and valuing of English, right? All right. And let's do it for the 3 cluster solution first. And what I want is descriptive statistics. And for now, I'm not going to do any postdocs. Now I get the means and the sample sizes for each of my clustering variables. So cluster 1 has a mean of 1.965 on appearance goals. Cluster 2 has a mean of 2.32. Cluster 3 has a mean of 3.349, like that. So you get these statistics, and it shows you, it starts to give you an idea of what your clusters look like. I'm going to do the same thing for the 4 cluster solution. And then I'm going to do it again for the 5 cluster solution. Okay, so I have produced the sample sizes and the means for each cluster on each of my clustering variables. You can see it's a little bit overwhelming to interpret all of these means. So it is much easier to try to interpret it if you graph the means, which I've done here. So if we take a look at the 3-cluster solution, we can see that appearance goals is in blue, and family orientation is in orange, and valuing of English is the gray bars. And what we can see is that, for example, cluster 1 and cluster 2 appear to be about similar in their family orientation, but cluster 1 is quite a bit higher in their valuing of English than cluster 2 is, and cluster 1 is a little bit lower in their appearance goals than cluster 2 is, and cluster 3 is relatively high on all 3 of these. Now, if we go over here to the 4-cluster solution, what we can see is this cluster here, cluster 2 from the 3-cluster solution that had 363 cases, has now broken up into a new cluster 2 with 117 cases and cluster 4 with 246 cases. And what you can see is cluster 2 now is relatively low on everything, and cluster 4 is sort of average on appearance goals and on valuing of English work, and quite high on family orientation. Now, if we go to the 5-cluster solution, we see that another cluster is broken up. The cluster that had 448 cases, cluster 1, has split up into this one, a new cluster 1 with 288 cases, and a cluster 4 with 160 cases. And what you want to see is, like, did I get a lot of bang for my buck here? Did this give me a lot of new information? So comparing this cluster here with these 2 new clusters, it looks like cluster 1 and cluster 4 are similar in their appearance goals and pretty similar in their valuing of English work, but cluster 4 is higher, a bit higher in family orientation. It looks fairly similar to cluster 1. So this is where the judgment comes in. Is there value added in dividing this cluster 1 up into these 2 clusters? Are they different enough from what we had before to make it worth adding a new cluster? I don't know. That's a judgment call. I don't think they're all that different. I think I would probably say the 4-cluster solution is the best. What you want is to get the most information you can out of the fewest number of clusters. Parsimony, meaning fewer clusters. So if you get a little bit more information with more clusters, I don't know if it's worth it. You really want to see a relatively big change. So for example, when we split up cluster 2 in the 3-cluster solution into this cluster and this cluster, we got 2 pretty different clusters than we had before. So that was worth it. And this would lead me to maybe want to stick with a 4-cluster solution. So now, once you've decided how many clusters, now what you can do is you can start to compare these clusters on other variables. I wonder how these motivational clusters might differ on some other variables. So for example, let's compare the means of the 4 clusters on something like self-handicapping. This is things that students sometimes do to undermine their own performance, so that if they don't do well in school, they can blame these other activities like procrastination or getting drunk the night before a test, or spending too much time with friends. They can blame those things for their low performance rather than a lack of ability. So let's see if these 4 clusters differ in their, let's see, I'm going to plot the means, see if they differ in their self-handicapping. And this time, let's compare each of the groups. Okay, so my 4 clusters differ significantly in self-handicapping by quite a bit. And if I look at the means, I can see cluster 2 seems to have the lowest self-handicapping mean. And cluster 4 seems to have the highest, but it's pretty similar to cluster 3. So if I look at the post hoc tests, I can see, okay, cluster 1 is different significantly from cluster 4 and from cluster 3. Let's take a look at this. All right, plotting the means, cluster 1 has a lower self-handicapping average than 3 or 4. And 3 and 4 are pretty high. Are 3 and 4 different from each other? 4, 3? No. So 3 and 4 are equal to each other. Are 1 and 2 different from each other? 1, 2? It's a trend, but it's not statistically significant. How about 1 and 3? 1 is different from 3. Okay, so now I'm ready to reach a conclusion. Clusters 1 and 2 are lower in self-handicapping than clusters 3 and 4. Let's go back and remind ourselves, what's the difference between clusters 3 and 4 compared to 1 and 2? Well, clusters 3 and 4 are higher than clusters 1 and 2 in family orientation. And clusters 3 and 4 also are a little bit higher than clusters 1 and 2 in appearance goals. So it seems that this combination of wanting to appear smart and having a desire to please the family might lead to higher levels of self-handicapping. This cluster here, cluster 2, they seem to be low on everything. They were also the lowest, I believe, on self-handicapping. So it's possible that cluster just sort of is low on everything. And they just answer, everything sort of low. Cluster 1 really looks pretty similar in some ways to cluster 3 on family orientation, a little bit lower, and valuing of the work, but cluster 1 is really quite a bit lower than cluster 3 on appearance concerns. The difference in self-handicapping may be driven by differences in appearance concerns, where really a desire to look better than others, to make people think that you're smart, might lead you to be more inclined to self-handicap, since that's a way of making people think that your failures are due to lack of effort rather than lack of ability. Okay, so that is how you perform a cluster analysis and then try to interpret the output that you get.